but in the majority of his experiments, he had to take the anthers off of one flower, take them over to this flower, cut the anthers off of this flower, sprinkle here, and sprinkle there. 28,000 times he had to make sure that these anthers did not do what?
Self-pollinate.
Did not self-pollinate. Sometimes he allowed them to self-pollinate, but over half of the time, he had to make sure that those plants, those flowers, did not self-pollinate. Now remember, we have a pea plant growing here. How many flowers are on a pea plant?
2.
1.
How many of you have grown peas before in your garden? You go out to the pea plant and there are little peas hanging, you pick them. And like green beans, the more you pick them, the more they grow. Every pea pod is a flower, or was a flower, right? So you can just think about one plant may have had hundreds of flowers on it, and he had to get to that plant. And before those pollen sacs opened up, he had to make sure that he cut those anthers off to prevent it from self-pollinating. Okay, so I think, you talk about meticulous, you talk about being tedious. That is very tedious work. You do that 28,000 experiments. What was his book work like? And his record keeping, what do you think?
Tedious.
What do you think?
Melbourne.
I don't think it was messy. Probably pretty stinking organized, right? And remember, he looked at not just round and wrinkled peas, but he looked at how many different characteristics? 7. So he would cross 7 different characteristics. Okay. So that, again, a lot of meticulous work, a lot of tedious work that really went into this. All right, if I get a volunteer, please, to read the last paragraph on page 58. Last paragraph on 58. Jake, thank you. Nice smile.
Mendel decided to find out what would happen if he crossed 2 plants that had different forms of a single trait. To do this, he used a method known as cross-pollination. In cross-pollination, the anthers of one plant are removed so that the plant cannot self-pollinate. Then pollen from another plant is used to fertilize the plant without anthers. This way, Mendel could select which pollen would fertilize which plant. This technique is illustrated in Figure 5.
Right. So the one thing that we really got to keep in mind here is ideally, or realistically, Mendel wanted to mix and match different traits to see what happened. That really was his goal. You take a round plant and you mix it with a wrinkled plant, what happens? What kind of peas turn out? You take a tall plant and you mix it with a short plant, what kind of peas turn out? The key is, though, before he even starts his experiment, what? You tell me, what is the key? He has to be sure of one thing before he start mixing and matching. What did he have to be sure of? We talked about it last week. It is critical. It is critical that he made sure of what? That each of the plants were
True breeding.
True breeding. What is a true breeding plant? Once again, someone who has not answered here in a while. What is a true breeding plant? If it's a round pea plant, good. If it's a round plant, that means when you do what with it first? You gotta let it self-pollinate, and if you let it self-pollinate, 100% of the time the peas are going to turn out round. It's almost like we said the other day, it is a purebred, like you're a purebred dog, where it only has information for that certain trait. Mendel had to be sure of that. He had to be sure if he was going to test, if he was going to mix and match a true breeding wrinkled plant with a true breeding round plant, he had to make sure that there was no dirty DNA. This plant had to have 100% round, and this plant had to have 100% wrinkle. It's no different than when you do an experiment. We talk about variables, right? When you start, how many variables should you be changing at the start of an experiment, or as you go through? How many?
1.
1. And so Mendel's, really his variable was to make sure, one of them was, hey, he wasn't going to do what? He was going to make sure that he started with a purebred. If you start changing so many variables, your results, you can't determine what you're going to, you can't determine anything. Your variables are not in check. So Mendel started with 2 plants, a true breeding round and a true breeding wrinkle. Let's read his experiment. One more paragraph we're going to read, and we're done reading, and I got a ton of notes for you to take on board. One more volunteer for the next paragraph, page 59, first paragraph. Someone who has not read in a while. Thank you. Yeah, we're start with Mendel's first experiment.
In his first experiment, Mendel performed crosses to study 7 different characteristics. Each of the crosses were between the 2 traits of each characteristic. The results of the cross between plants that produce round seeds and plants that produce wrinkle seeds are shown in figure 6. The offspring from this cross are known as the first generation. Do the results surprise you? What do you think happened to the traits for wrinkle seeds?
Okay, so let's take a look at, just to go to the picture. You can see what he did there.